Capital budgeting is planning expenditures on assets when cash flow extends more than 1 year. So more than 1 year means interest is involved, right? Interest rate is included. For the capital budgeting, the company wants to know if the expected value of the cash flow from the project is less, equal, or greater than the cost of project, and also expected rate of return on the project is less, equal, or greater than the cost of fund required to take the project on. So company for capital budgeting, the company want to compare investment cost against benefits of investment. In terms of value, well, usually we talk about the present value, and in terms of rate of return. We mostly want to use present value of future cash flows and rate of return. A payback period is a number of years or any period required for the project's cash inflows to repay the initial investment. So in this example here, initial cost is $70,000 today, and then year 1 cash inflow is expected to be $30,000, year 2 $35,000, and year 3 $40,000. So year 1 and 2 together, the project will recover $65,000, right? And then remaining $5,000 will be in year 3. So $5,000 over $40,000 is multiplied by 12 months. That is a month, one and a half month. So to recover a whole $70,000, it takes 2 years and 1.5 months. That's payback period. It's not using discounted value. Now we can use discounted cash flow. So we want to, this is already present value, well, current cost, and then if it is discount rate is 5%, then discounted value, the present value of $30,000 is, we multiply by how much? Well, it should be $30,000. Well, it is $30,000 divided by 1 plus 0.05, right? Is $30,000 divided by 1.05. Well, I get 28,571. Okay. For this one, it is for 2 periods, so it's going to be $35,000 divided by 1.05 squared, right? So it is, I get 31,746. For this one, $40,000 divided by 1.05 cube, and then I get 34 554. We add up all of those numbers. No, we don't have to do that. And then we add up these two, then it's 6317, right? Then how much is more remaining? 70. And then 70,000 minus 6317 is how much is remaining? 9683, right? So this much must be recovered in year 3. So in year 3, 34,554 will be recovered. So we can figure out how many months we need to use from year 3. So it's going to be 9,683 over 554. Then it gives me, well, we multiply 12, right, on this, and then 336. So discounted cash flow payback period is 2 years and 3.36 months. So it should be in April, right? In year 3, April. The net present value is defined as the sum of discounted all discounted future cash inflows and cash outflow. Current cash outflow is minus, right? Because it flow out, right? And then this is positive. And then if that is greater than 0, then we know it's going to add value to the company. So wealth of the company goes up. So the company accept the proposed project. If it is negative, then it's not going to make money, so they will reject the project. This is the formula for the net present value. Cash flow 0. This is cash outflow, so it's negative number. And all of these are positive numbers. Cash inflows, right? Cash inflows are discounted by discounting factor, discounting rate R, like this. And then or sum of these plus numbers and minus number, minus the cash outflow, is net present value. This can be greater than 0 or less than 0, depending on the project. So let's look at one simple example of net present value and then see how to calculate net present value. So discount rate is 5% here, and then let's use one simple timeline here. 0 times 1, 2, 3 here. In time 0 now we have minus $1,000 because it's cash outflow. That's dollar amount, and then $600 at the end of the first year, and $400 income at the end of second year, and $200 of income inflow at the end of third year. Then we want to find all present values of all of these future cash inflows. And then, well, discount rate is 5%, so we want to discount 600 by dividing 1 plus 0.05, right? And then this is discounted by two periods, right? So 400 divided by 1 plus 0.05 square. And then this is divided by 1.05 cube. And then this, I get the numbers here. I get $571. And then 363, and then 173, and then we add these all up, minus $1,000 plus 571 plus 363 plus 173, and then it gives me $107, which is greater than 0. That means this much value is added to the company's value went up this much. So this is positive, so that means it is this project or this investment is profitable, so the company will take the project. So it's because it's going to make money. The IRR, internal rate of return, is the discount rate making net present value equals 0. So if IRR is greater than the cost of capital, then take the project. So in this case, if IRR appears to be greater than 5%, we are going to say this project or this investment is profitable, so the company will carry this project. So to find out IRR, the best way of finding IRR is using a financial calculator. So we also can do trial and error, but it's tedious, it takes a long time. And or Microsoft Excel has a function of finding IRR, but usually we use a financial calculator. I recommend you to use TI2 plus or other types of calculator. So net present value should be 0 here, and the net present value is calculated by adding all of these terms. Cash flow 0 is minus 1,000 in this case, in this our example. Cash flow 1 is 600. Cash flow 2 is 400. We have cash flow of 200 is the last one. And then solve this for IRR. Find out IRR, and then that's going to be greater than 5% or not. Our threshold was 5%, so we compare IRR against 5%. So we can use a financial calculator using that calculator or other kind of calculator. If you buy a calculator, the calculator has the calculator comes with the manual. Manuals explain how to use your calculator to find out IRR and net present value, all kind financial answers. Now, modified IRR is discount rate that makes present value of cost. In our example, present value of cost is already $1,000 given, right? Should be the same as present value of terminal value. Terminal value is actually future value. Let's use our example using timeline here. And then minus $1,000 is cash flow 0, right? Cash flow 1 is 600 and 400 and then 200. Then we want to find all of these cash flows at the terminal. Well, we multiply by 1 plus 0.05 and then gives me 420. 600 times it's gonna earn 600 will earn what, how much? 2 periods of interest, right? So it's gonna be 1 plus 0.05 square, and that is, to me, it is $661.50. So total sum of these three numbers is $1,282. That is called terminal value. Okay. So what we need to do is the cost equals present value of terminal value. So IRR is discount rate when cost equals present value of terminal value, right? So we have cost is $1,000. What is present value of terminal value here? So $1,282 divided by how many periods should be applied here. This number is at the end of third year, so we have 3 periods to discount to get present value of terminal value, right? So it's going to be 1 plus modified IRR cubed, right? Okay. So we need to solve this to find out MIRR, right? So here, let me do this right here. So to solve this is unknown. So we can change this one here. 1 plus MIRR is well 1,282 divided by 1,000. So it's going to be, well, actually this cube, right? Cube equals 1.282. So to solve for MIRR, we need to take this out, right? So 1 plus, well, so we put a cube root on both sides. 1 plus MIRR is plus, okay? 1 plus RR equals 1.282 cube root raised to the 1/3 power. So again, 1 plus MIRR equals, well, you can solve this one. You can solve this one using your calculator, and it gives me 1.0863. So MIRR equals 1.0863 minus 1, you see? And it gives me 0.0863, which is 8.63%, which is greater than 5%, our initial discount rate. So well, it is profitable. It tells profitable. This project is profitable, so the company will take the project.